All right, so in this final section of chapter 1, we're just going to quickly review the Cartesian plane. How do you plot points in the plane? What are the quadrants? That sort of thing. And then we're going to recall two important analytic geometry results, namely how you find the distance between 2 points in a plane and how you find the midpoint of a line segment. And then we're going to use those to find the equation for a circle in the plane, and then how to find that depending on what information you have. All right, so let's first look at it. The Cartesian plane, basically the xy plane, is comprised of two copies of the real line intersecting at 90 degrees, right? And so if you take the real line as the x-axis, the real line as the y-axis, and intersect them, the common point of intersection is the origin. And if you want to plot a point in the plane, the first coordinate is the x, the second coordinate is the y. And so in terms of quadrants, we're assuming that moving along to the right in the x direction or up in the y direction is the positive direction. And so points in the first quadrant, we'll say, this first upper box, both have an x and a y that are positive. Whereas over here, moving to the left along the x-axis gives you a negative, moving along the upward direction of the y gives you a positive. And so in the second quadrant, points have a negative x and a positive y. And then similarly, in the third quadrant here, both coordinates are negative. And in the fourth quadrant, the x is positive while the y is negative. All right, this is called an ordered pair because the ordering actually is important, right? The first one is x, the second one is y. You can't just flip them around and expect to get the same point back. All right, so for instance, here, go ahead on a xy plane, go ahead and try plotting these 5 points and see what you get. All right, so if you do that, here are the results. 4, 1 is in the first quadrant, x is 4 and y is 1, and so you go over to the right 4 and up 1 to get A. For B, both are negative. You go -1 in the x and -2 in the y to get that positioning. For C, notice that the x coordinate is 0, so you never moved away from the y-axis. So you just go from the origin straight down to -3, right? So that is a y-intercept, so to speak. That'll be a term that we talk about next time. 5, -1 occurs in the fourth quadrant. Move 5 to the right and 1 down. And then 3, 0 is a similar idea to C. You never leave the x-axis and just move 3 over to the right. All right, so let's look at distance, right? We already know how to compute distance along the real line. We'd introduce the absolute value to do that. But now if we're in the xy plane, now position requires 2 pieces of information, an x and a y, like I have shown here, right? So I have a point, we'll call it x1, y1. The ones here are just indices. They're subscripts that indicate just a label, that's all it is. You could have very easily just called them AB if you wanted to. And then I have another point, Q, we'll call it x sub 2, y sub 2, right? And suppose I want to know what the distance between P and Q is, right? And I'm labeling that as D parentheses P comma Q. That's a common way of denoting distance between 2 points. All right, well, I don't know how to compute that right off the bat because it moved both in the x and the y direction, right? And so I don't know how to compute that using what we know. But what you can do is form a right triangle by keeping this height always at y1 and this x coordinate always as x2, right? So if I look at the point R with x coordinate x2 and y coordinate y1, notice that QR, that segment here, is vertical because I never changed the x coordinate, right? The only thing that's changing here is the y coordinate. And similarly here, the segment PR, well, that's horizontal because I never changed the y. It's always y1. You say, well, so what? Well, 2 things are important. One, I know that I formed a right triangle, right? So if I can manage to find the lengths of these sides, that old Pythagorean theorem that you learned about will kick in and we'll be able to use it to express the length of this side in terms of them. Well, the question is, well, how do I compute the lengths of these sides? And that was where step 2, or the second reason why we did this, comes into play. This is basically a copy of the real line. If you want its length, right between those 2 points, all I have to do is subtract the y coordinates and take their absolute value, right? The reason I take the absolute value is that these are just labels, and so it could very well have been that y1 was higher than y2. I don't know. Depends on my picture. But in any case, the length of this side is the absolute value of y1 minus y2. And same way here, the length of this side, the only thing that's changing is the x's. So I just take x1 minus x2 in absolute values to find its length. Okay. You could also subtract it in the opposite order. Doesn't matter. Okay, well then I had the length of each of those sides. By the Pythagorean theorem, if I square the length of this side and square the length of this side and add those, I should get the length of that guy squared. All right, that's what I have here. To get the actual length, I have to get rid of this square. And so what I'll do is I'll take the square root of both sides, right? And that gives me this formula, okay? So the distance between 2 points is the square root of the sums of the squares of the differences between the x and y coordinates of those points. Think of it verbally like that. All right, so let's go ahead and look at example 1. If I want the distance between those 2 points, all I have to do is subtract the x values, so 4 minus 1, square it, and then add to that, subtract the y coordinates, that's minus 1, minus 3, square it, right? So let's compute the inside. I have 3 squared and negative 4 squared. That gives me 9 plus 16, which is 25. Take the square root of that end result to get that the distance between those 2 points is 5 units. All right, so you go ahead and try these two, right? Exactly the same thing, just be careful with negative signs when you're subtracting. That's the only thing that you really have to be worried about. And remember, you're subtracting the x's and the y's of each of those points. All right, so if you do that, again, the setup is the same. I'm subtracting the x values, so I want minus 2 minus a negative 1, so I have a double negative here. All right, so that turns into minus 2 plus 1, which is minus 1. And then here I have minus 3 minus 4, no double negative. So if I simplify this, I get negative 7. Square both of those, you get 1 plus 49, which is radical 50. And yes, technically you can simplify that using the results we talked about earlier. That's just 5 root 2. Similarly here, when you have zeros, it's even easier yet, right? If I subtract 0, I don't change the value. And so I'm just getting minus 4 squared here and positive 4 squared there. Both those give you a 16, which then when you add them gives you 32. And that, if you simplify, gives you 4 root 2. All right, so distance formula, not too bad. Now, how about the midpoint? All right, so let's look at a picture. I give you the same old 2 points, and suppose I want to find the point that is smack dab in the middle of those 2 points. Well, the question is, well, how do I do that? Well, the only way you're going to be in the middle of those 2 points is if you went halfway from x1 to x2, and you went halfway from y1 to y2. In other words, if you went any more than halfway from x1 to x2, you're going to be further along horizontally on this segment, so it wouldn't be the midpoint. Same way here, if you didn't go exactly halfway between y1 and y2, you'd be higher up. And so we know that we have to find the middle points of each of these 2 segments, and then you have to use both of those to get the midpoint of the diagonal segment. Okay, well, to find the midpoint of this segment, all you have to do is find the average, right? That's what you would do to find a midpoint. So the average of x1 and x2 is the sum divided by 2. The average of y1 and y2 is the sum of y1 and y2 over 2, right? And so the midpoint has coordinates x1 plus x2 over 2, so the average of the x's and the average of the y's. All right, and so let's find, here's the example. This is the same example we did before, but now with the same points, but now we're asking for the midpoint. So if I want the midpoint between these 2 points, I'm going to add the x's, 4 plus 1 divided by 2. I'm going to add the y's, minus 1 plus 3 over 2, and simplify to get 5 halves, comma 1. So this is the point that is right directly in the middle of the line segment with these two endpoints. Just bear in mind, that oftentimes when people have the midpoint formula and the distance formula together, the tendency is to mix up which one you're subtracting in and which one you're adding in, right? So it often helps to think about the picture in this case, just to kind of remind yourself which one's which. All right, for the your turn, it's the same points you looked at in the previous one. Go ahead and apply that midpoint formula to find the midpoint of each of these segments. If you do that, just check yourself that you got these coordinates back. Again, the only thing you have to be careful of is the negatives and that you're actually adding the x and the y's each time, not subtracting them. All right, I'm going to let you read example 3, but suffice it to say that if you have a distance formula, now you can find the perimeter of any sort of region that's comprised of line segments in the xy plane, right? So perimeter is the distance around, right? So that's a common thing that we ask you to do in the calculus and word problems, right? And so to find the perimeter of a triangle, all you have to do is find the length of each of those 3 sides. But the minute you have the coordinates of those 3 points, which we have, you can use the distance formula to find the lengths of each of those segments and then add them up to find the perimeter. Okay, so I'll let you read through that, but this is the calculations behind doing that. Okay, and now finally, we want to talk about circles, right? And what you already know about a circle is that basically there's a center, and the way you get on the circle is by being the same exact distance from the center, right? So you have a radius that tells you that distance, right? So we have a point here and a radius, and the way a point x, y gets on the circle is by being that distance away from the center, right? And so all these points are there because they're a fixed unit or fixed distance away from HK. But that tells you right there, just the description alone tells you how to find the equation of a circle, right? You're going to use the distance formula. We know that xy is on the circle if its distance from HK, which is the left side, right? We have 2 points. Use the distance formula to find the distance between those 2 points. If that distance is this radius r, so is means equals, right? So if that distance equals r, then xy is on the actual circle. Well, now what people typically do is from here, they square both sides because people don't want to deal with radicals. And so what we'll say is that the standard equation of a circle centered at HK with that radius is equal to the radicand. It's that squared plus that squared equals r squared. Keep in mind here that these negatives are part of the formula. You can't ignore those, right? They have to be there. Okay? All right, so let's actually look at this example. So first, I want to find the equation of the circle with center 3 minus 2 and radius 5. So all I'm going to do, we know the center is HK in this formula. I'm going to plug in 3 for H, minus 2 for K, and I'm going to plug in 5 for R. Right, that's the very first thing that I do right here. Notice right there I have parentheses around the minus 2, right? Because the minus here has to be brought down as part of the formula. And so what I'm going to get in this particular part is y plus 2, right? Not y minus 2, y plus 2. This guy is x minus 3 because it was positive to begin with. And so you have just x minus a positive 3. If you square 5, you get 25. All right, so this is the standard equation for that particular circle. Okay, and then for here, I give you the equation of a circle, and I want you to find the center and radius. So the idea is to then be able to first write this in this form, right? So, and that means the negatives too. So when I have x plus 5 squared, I want to write that as quantity x minus something squared. And same way here, I want to rewrite y squared as y minus something quantity squared. And I need to write the right-hand side as something squared, right? Because it's r squared. So to do that, notice that x plus 5 squared is just x minus a negative 5 squared. So the double negative produces that plus. You're not subtracting anything from y to begin with, So subtracting 0 does you exactly the same thing. And then now we know that the number squared that gives you 2 has to be root 2 by definition. So you've written that equation in this form. I can now pluck out what the coordinates are. The x-coordinate of the center is -5, the y is 0, and the radius is root 2. All right. Again, try this your turn, see what happens. Just be careful with the negative signs. Okay, and I'll put the solution up here momentarily. Okay, so for the first one, I'm going to put in -6 and -2 and for h and k respectively in the formula. And I'm going to square the 16, because the right-hand side of the standard equation of a circle is the radius squared. It's not just the radius. All right, so I get x minus a -6 squared. That's x plus 6 squared. Same for this term. And if you square 16, you get 256. To find the center of this equation, I'm going to rewrite each of those as x minus 0 and y minus 0 squared each time. And then I'm going to rewrite the right-hand side as radical 3 squared. The center is at the origin, and the radius is root 3. Okay, finally, let's look at this. Suppose I want to find the equation of a circle that has the points -6, 7, and 4, -1 as endpoints of the diameter. Okay, so if I want to do that, right, I know that a diameter has to pass through the center of a circle. That's by definition from high school geometry. And so that actually tells you a lot. We know that these 2 points are endpoints of a diameter, and so the midpoint of that segment has to be the center of the circle, because each of these points being on the circle has to be the same distance from the center. The only way that's going to happen is if the center lives exactly halfway between them. So that's great. We know how to find the midpoint. Just use the midpoint formula with those 2 points. Similarly, I need to find the radius, but the radius is equal to the length of the segment from 0 to one of those points. Well, I have these 2 points. All I have to do is find the distance of the whole thing, or the length of this whole thing, and then take half of it, right? So if I use the distance formula and take half of it, that'll give me the radius. All right, and so here is the work done for that. I have the midpoint formula here. Add the x's, divide by 2, add the y's, divide by 2, simplify to get that guy. And then for the distance formula, I'm going to subtract the x values. Or I guess instead of what I did here, you could do this one of 2 ways. What I could have done, what I was talking about doing, is finding the length of the whole diameter and taking half of it. But technically, if you have the center, you can get the radius directly by using the coordinates of the center, which is -1, 3, and one of the points, let's say 4, -1, right? That distance would equal the center. You don't even have to divide it by 2. So if you do that, apply the distance formula in that case, you do get radical 41. And then if you plug them into the formula, -1 in for h, +3 in for k, and then radical 41 for r, you get that the standard equation of that circle is that equation. All right, so as usual, just go ahead and try these problems out. This is the video supplement list is there if you need it, and just see kind of what happens. Let me know.